Hello sir, this is the workbench. Here in the workbench we are going to show you the how we are going to use the micromechanics. Here is the material designer. We are using the material designer here. We have used it the material designer. We are going to put it RVE, capital RVE. Now in the engineering data we are going already default is the structure steel. We are going in the engineering data source. We are going in the Ansys Granta, which is one of the dictionary of the material, and we are going in polypropylene or any plastic PC, PET, and PP. I got the PP. We are going in the composite material. When we are going in the composite material, we got the E-class. E-class, when we got the E-class, we have gone back in the project. We have gone in the project, then we have the save new material designer. Let's see how it is. Hello sir, this is Ansys material designer. Here we are going to select the material at the top, but you see in the left side there we are not getting any instruction block. So first we have to select the RVEs. At the top there is a lattice, unidirectional composite, random unidirectional composite, short fiber, woven, particle composite, honeycomb, and this is the user defined. Here whatever the design is not available in the here, so we can define it here. So we are using the woven composite here. We have clicked it. See, the material has come. We have using the matrix polypropylene. Here the yarn we are using the E-glass and we are just sticking it. So material we have given. So matrix we have given the polypropylene, yarn the E-glass. In geometry, first I am going to show you what is inbuilt geometry. This is the inbuilt geometry. Here in the inbuilt geometry, you can see they are using the fibers which are at 45 degrees, and that is having the thickness of 0.2 that you can go and you can check it. This I have selected, this I have selected, that you can say the distance is 0.2 between the two, and this is of 1 mm. So they are using the RV of 1 mm, so 1.41 है ठीक है. Here it is using 1.41. So I'm not interested in this because I have my own yarn fabric cloth, so I'm going to use it differently. Okay, plane, I'm using the plane. Fiber volume fraction I have to use 0.5. This I can make parameterize. I can do the parameterizations by clicking it here. Okay. Okay, fiber volume fractions I'm taking 0.8 or 0.9 I can also take, as it is a well defined. Shear angle is the angle of the fiber between the two fibers orientation. The spacing is 0.5, that I will tell you what it is. That is 0.37. Align along the x directions. Align yarn with the x direction is what? If you will see, these are the x, so this has aligned along the x directions. Okay, this I have just removed it, so it is going arbitrarily already whatever the angle they have given, so that I am aligning it. Or you want to give another angle, so here you can give that shear angle, but I am using that one, so this has come. So now here I can show you, I have given the thickness 0.37. I am selecting this. Okay, and I am selecting this, so you can see the thickness is 0.37. I am finding that the length is 1 mm. Yarn spacing, actually yarn spacing is the spacing between these two fibers, so that is a 0.5 mm. 0.5 mm, you can see it. It is clearly visible here. Okay. So now I'm going to the mesh. In the mesh, you have to take care that this is you are giving the mesh size in the mm. So 0.1, 0.2, 0.3, giving 0.3 mm the mesh. And you can see this is the conformal meshing and the periodic meshing. In the conformal meshing, the sides of this RVE will having the same sharing nodes with the other RVEs for the periodic meshing. I say okay, mesh it. Okay, they had mesh it. Execute this. Oh, is no. Everything has done. Oh, mesh failed. Why the mesh failed? Why? There is something happened wrong. Mesh failed. Can I try something else? Then I am trying 0.2. Oh, still the mesh cat failed. Why it is going to be failed? Here we don't have the much control on the mesh size, so I'm using 0.4. Why the mesh is going to be failed? Yes, actually we don't have the control on the mesh here. 0.4 mm, so I'm going to much smaller. Okay, 0.1 mm. Let's see. Okay, now it has meshed properly. I think I was giving the much larger dimensions. Okay, that's not a big deal. The settings you can go. I want the orthotropic properties, that is compute the linear elasticity, use the periodic boundary conditions. Yes, they have to use the periodic boundary conditions in the analysis. I am saying constant material and I am saying solve it. Okay, now you can see these are solving the six equations. From these six equations, I am explaining what they are solving. The first equation is solving by putting the uniaxial normal strain. The second, it is solving the uniaxial in other direction, x, y, and z unit strain. Then it is going to uni short out the unit strain, shear strain in every three directions. So six equations actually it is solving to find these constants. Just पूछेंगे आपके साथ मैंने पूछा है glass fiber polypropylene. I put it like this. Oh, results are available here. You can see it. I am happy to see the result. It is matching from my last result. So this is Deepak Maurya. I think you have enjoyed these things. Bye.